So yeah, the idea of inheritance, what we were talking about last time, was like when I inherited, we made a bag interface, and then we made an indexed bag and also a sorted bag. My goodness, pardon me. Huh. But the index bag and the sorted bag were both bags. So we inherited from the bag. We extended it. Is the resolution not good? Is the resolution really bad? Or just luck for me? Maybe it is bad luck. I don't know. Other people, let them know if it's okay. Hopefully it's not too bad. Yeah, it's like usual. Okay. See if there's anything. All right. Well, here's hoping it improves a bit. What was I saying? Yeah. So the extends. When we wrote array or indexed bag extends bag, we got everything from bag, but then we also got to add additional stuff to make it specifically an indexed bag, which was cool. Now, the idea of polymorphism is where we're going, which is really cool. Oh no. I've got an issue here. What's going on here? My stack, new array stack, new link stack. These should be on new lines. Someone can go totally fix this with a PR, and you'll contribute, or at least make an issue. So yeah, this is a problem here. It should be on new lines. So polymorphism is the idea that behavior can change depending on the type of the object. We've already made use of this idea without really having gone into any details. So we had a stack. Well, we had an array stack and a linked stack. They were both stacks, right? I could say stack, my stack equals array stack, or I could have said equals new link stack, and they're both stacks. Our reference variable is for something of type stack, yet it can reference an object of type array stack or linked stack because array stack and linked stack is a stack. But I could never do anything like, make an array stack equal a linked stack, because that's not an option. An array stack is not a linked stack. This is because, a linked stack is not an array stack. Okay, warning. We did something like this. If we did something like this, the data, both my stack and reference, has the type linked stack. Okay, so have a look here. I forgot what this point was making. So I've got a stack reference variable called my stack, and it equals a new linked stack. So my stack is a reference variable to something that's a stack. So let's draw here. I've got my reference variable. This is called my stack. And then somewhere over here, I've got my stack. So this is my stack. It's this circle, right? So this right here is an array stack or link stack, whatever. This is what we have. And we have a reference to this. Because my stack is a reference to a stack, and an array stack is a stack. But then immediately below, I say object O equals my stacks. And what this creates is a reference variable called O. But the reference variable, it has to reference something of type object. Now, because of inheritance, we know everything is of type object. Every single thing there is a subclass of type object, meaning an array stack is also an object. So here, I have my stack at the top right here. I have my stack, which is a reference variable to a stack, and I have O, which is a reference variable to an object. But over here, I have the actual object. the array stack. This is where the actual thing is. So regardless of accessing my stack or O, but regardless of using my stack or O, these two reference variables to access this array stack, they're an alias for the exact same array stack. But no matter what, the object that's array stack is still an array stack. No matter what. Why isn't O a reference to my stack? Well, what? I'm not sure what you mean. Do you mean like, why is it not like this? Is that what you mean? Because that's not a thing. Because you can't have reference variables referencing reference variables. You have reference variables referencing objects. And remember, when I say O equals my stack, I copy over the contents of my stack, which is the reference to this object right here. So I copy a reference to this object. Right? Remember, people whenever talking about like references, they try to make it more complex than it is. What happens when you use equals? Well, it's an assignment. You copy over the contents of what's in my stack and move it into the other thing. Would the analogy be putting a label on a label work for that? I'm not sure. I'm not sure what you mean. Because to me, a label on a label would be more along the lines of, where the heck? Would be more along the lines of doing it this way, that's no good. So remember, I'm drawing these as arrows. But really what we've got here is like the information I need to get to this. So this is going to be like, oh, OX. I don't know, some arbitrary memory address, okay? I'm using the arrow to kind of mean that. But when I come along and say, okay, oh shoot. What did I write? Oh, okay. Yeah. When I copy over the contents, I'm copying over this. So it's like the memory address of where that object is. I'm drawing them as arrows, but remember that I'm copying over what's inside this variable, which is just that memory address, the reference to the object. I think you guys should think of it the way he's explaining it. Oh, burn. Sorry, that was really funny. But hopefully, elongated in Bilbo. Did that answer the question though? Because remember, when we create the new, this returns the memory address. So that means like that's what we're putting in here. And then when I say my stack, I get the contents of my stack and then paste it in O. All right, cool. All right. So the point I'm making here is like this is where polymorphism pops up, where like, okay, well, we can have a reference variable, like an object can be referenced by things of different reference variables, right? So I've got a reference to an object and a reference to a stack, but like this is all valid. So there's this idea called binding. So let's say I have this code right here. All right? Look at this code. Actually, here, no. We'll start by looking at this code. Just this one line right here. I write this in my main, okay? Before I hit run, even before this program starts running, Java knows what the thing my stack references, right? It knows it's a linked stack. Why? Because I literally wrote it there. I've got the stack reference variable called my stack, and it's a new linked stack. And then if I go on and I'm using it, great, it's a linked stack. It knows. So even before runtime, at compile time, Java goes, oh, okay, I've got this my stack variable for a stack that's referencing a linked stack. Great. But the problem is, look at this. I create a stack reference variable, and then I roll the dice. I get a random number between 0 and 100. And I say, well, if it's less than 50, make it an array stack. And if it's greater than 50, make it a linked stack. And then I say push, 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 and then print out the stack. Great. The problem here is Java cannot know at compile time what the type of the object being referenced by my stack is. It'll only know at runtime, because whether it's the array stack or the link stack, it depends on something that happens at runtime. So if this is just a line of code and I compile the code, Java goes, yeah, okay, I'm making a linked stack and it's referenced, great. But here, it won't know. It won't know if I'm saying myStack.push. It doesn't know until we get to runtime. It doesn't know if it's pushing on an array stack or a linked stack. It doesn't know. But then again, it doesn't really matter in this particular case, because both have push and they both should be working properly, right? Well, wait, okay, when you say real value, what do you mean? It's not so much about a real value. It's just we don't know what the type the myStack stack is referencing until runtime. It's called like late binding. So given the above code, which version of the toString will be called? myStack or linked stack? We don't know, right? Because I don't know if it's going to run I don't know if we have an array stack or a linked stack. I don't know. But if I had this line of code followed by a printout myStack, it's a linked stack because there's no ambiguity there. Where here, it depends on what the random number is. All right, connecting a call of a method to the actual implementation of the method is called binding. So, right here, we're saying myStack toString. Okay, we're calling the toString method. I realize we didn't explicitly say .toString, but remember, if we ever print it out, it does that for us. So we're calling toString. Java knows, oh, they're making a method call to the toString. Great, that's fantastic. But it doesn't know until, when it gets bound to which toString is it actually running will depend. If it's at compile time, we have static binding. So let me just go back and double check here. Hold on, let me switch it to this. Is this right? No, hold on. Okay, yeah, this is the one I want. Where's my... All right, here we go. So if I say stack of type integer, oops. New linked stack. S out my stack. Right? You know what, here. I'm even gonna add these here because makes it more interesting, right? No. Let's get rid of all that. Okay. When I run this, and I ask you, okay, we're calling the toString on a stack. Now, stack is an interface, meaning that there's no actual implementation of toString there. So Java needs to go and be like, they're calling the toString, but where's the toString actually? Where is it? Well, here, Java goes, well, at compile time, they made myStack, which is absolutely a linked stack. So I'm going to bind it with the linked stacks toString. So this goes and runs the linked stacks. Do I have a linked stack in here? Linked stack. This goes and runs the toString, which of course isn't in here. So there, it goes and runs that. It knows it at compile time. This is static binding, meaning like it's stuck, it's there, we're set. But sometimes we don't know until runtime. This case, we roll the dice. And this is called dynamic binding. If you want to know though, so here's a big one. If you ever want to know what the type of an object is, you can always ask it. I can say myStack.getClass. All right? Because if I have, like, you know what, let's write this. Let's do this. Okay, give me a second, because I can never remember. Okay. So I'm gonna say int, okay, math.random. So what does random return? I think it gives me like a number between 0 and 1. Okay, so I'll say 0 and 1 times 100. Yeah. There. And what's it whining about now? It's a double. There. Now I'm saying be an int. Okay, great. All right, so here's what this code is saying so far. This is just, okay, generate a random number between 0 and 1. Well, I want a number between 0 and 100, so I'm just gonna multiply that by 100 because there, now it's between 0 and 100. And then I'm taking all of that and being like, okay, be an integer, because by default, this will have a bunch of decimals. I don't want the decimals. We'll keep it simple. Hey, random question. Was just wondering how it, yeah, that's not a good question for right now. Maybe maybe that's a question for another time. So we get a random number, and then I say if random is less than 50, we will say my stack equals a new array stack. Else, my stack equals a new linked stack. And then I've got these, and as out, my stack. So this is going to be annoying because we don't actually have, here, let's just do like my stack.size. There. When I run this, like it's going to work just fine. It's 3. Every time I run this, it's fine. There's nothing wrong with this code. But I can't tell you right now, was that an array stack or a linked stack? They're both stacks, but which one was it? Which is kind of like funny, right? Like we don't know, but I guess it doesn't really matter. But if you really wanted to know, you could say my stack dot class get class. I think that's what it is. So let's see if I hit run on this. Ah, so that time it was a linked stack. Let's run it a bunch of times until we see an array stack. A linked stack, linked stack, linked stack, linked stack. Okay, now I'm worried that something wrong. Ah, there we go. Finally an array stack. Linked stack, array stack, array stack. So every time I hit run, I don't know until it's running what it is. Which is kind of like interesting. But a lot of times that's not going to matter, because for all of this, did it really matter if it was an array stack or a linked stack? No, because they're both stacks. So you can even actually say, well, what if you wanted to act a certain way depending on which like stack we've got? So you can actually ask the question, is my stack instance of, this is a big one, instance of array stack? If it is, so was stack. And then I guess either way I'll still put up the size. So let's run this a couple of times. Run. It was an array stack. Its size is 3. It was an array stack. It was an array stack. It was an array stack. I guess it wasn't an array stack that time. So now you can actually use this instance of operator to even check what the instance is, if you care. I heard a boop. What is instance of? It's an operator that just tells you, is this thing an instance of array stack? Right? I could say object. And that'll always be true. In fact, IntelliJ is going to be like, condition's always true. Yeah, that's funny. Yeah. Yeah. So that's that, which is pretty neat. Is that the same as getClass? Not quite, because getClass gives you back a... Here. So getClass is something that's inherited from the object. But what is getClass? So yeah, you could say like getClass.getName, but that gives you back a string where instance of, like this is a class, where getClass is, like if I say getClass.getName, that gives you back a string. So you just gotta be careful what you're comparing it to. This is kind of, it's similar to like the getClass, but it's a little bit different. Just be mindful of that. What happens if we get getClass? Let's see what happens, just for fun. So it's a class, java.lang.class. So that's interesting because it looks like my stack getClass returns a class object, which is kind of neat. So let's see what happens. Maybe this actually will work. Let's see. Instance of, no, my stack.getClass. What? Didn't I just use it here? My stack. I don't know, maybe, I guess maybe it's unhappy. Let's not try to break something, I guess. Array stack, cool. So just some neat stuff. So this is the idea of polymorphism. And you've been using it whether you realize it or not. Okay, getClass. Okay, for next time, you can go over the aside on concrete types and how inheriting from, or using inheritance in concrete types can become quite a bit of a pickle. So we like to avoid that. Yeah, so any questions about that inheritance stuff? I mean, I just talked a lot about it at you, and we're about to see examples of this used when we implement the actual like bag stuff, the array bags. But yeah. All right, so let's move on to array bags. We already know what we want to do with our bags. Why? Because, well, that's what topic 13 was all about. And we also want to extend the bag to make more specialized types of bags, an indexed bag or a sorted bag. So let's implement them now. Let's make an array implementation. And what do we got here? So we want our bag. The array implementation is going to be very similar to a stack and a queue, where we just got some reference variable to some array that's going to be references to the objects of type T. It'll be generic. We keep track of the rear, I guess, in this particular case. With the bag, though, you know, like with the queue, we wanted to keep track of front. But I guess with the bag, because the whole first in, first out, and the order not mattering, like we're not going to be like we have no reason with the queue. Whenever someone DQ'd, they were always pulling from the front, and if the front was always index 0, then we'd be doing. We know we would be doing a lot of shuffling. But also with the queue, we knew that you're only ever allowed to remove from the front. With the bag, there's no constraint on that. We can add and remove things, you know, whatever, however. But, so there's no real need to have a special way to deal with the front being removed, because removing the front is just as likely as removing like the 4th thing or the 17th thing. So, you know, with the queue, because of the constraint of only removing from the front, we could make it so our DQ, our remove, had a constant time operation with our fancy circle array, right? But with the bag, yeah, we don't have a guarantee that we're removing from the front. We can't guarantee it's being removed from anywhere. So because of that, I can't take advantage of that and write this general purpose constant time remove. I need the remove to be general. And if we've got this array, we're definitely going to introduce gaps. So we're going to have to be doing that like shuffling down or up stuff. So we don't really have that awesome feature, which really was just a constraint caused by the queue. I worry what I was just explaining didn't make sense. Let me know if that didn't make sense, and maybe I'll try to re-explain that. Okay, we definitely will need expand capacity. It's an array. And fortunately, we can use the simpler version of expand capacity, right? Because the front's always index 0. And what functionality do we want? Well, we want our add, remove, contains, get count, is empty size, and iterator. Again, I know we're talking about iterator. I think it's the next topic now. Yeah, iterator, but that's what we'll want. All right, so let me go. Remember with the queue, whenever you remove something, it had to come from the front. And when we had a queue and we said index 0, the idea 1 of the queue, this would be the queue you implemented in the last lab, the rudimentary array queue. If you used idea 1 where you always had it, so where the front was always index 0, whenever you dequeued something, you had to move everything down the array a little bit to fill in the gap that you just created. If you remove the thing at index 0, well, now you need to move the thing at index 1 into index 0 to take its place. Move the thing at index 2 into index 1 to take its place, and so on and so on and so on. We had to move everything down 1. But we took advantage of the fact that, like, well, you know, we're always removing from the front. So, and we can take advantage of knowing this information, and we can use this circle array idea to make it so our dequeues can be constant time. Right? And all we have to do is just keep track of where the front is, and we loop back. Where if we used idea 1 of the array queue, the rudimentary array queue, then the dequeue is always linear, because we had to move everything down 1 cell. So why that worked was because, well, we're always moving from the front, so we can eliminate any need for a shuffle by just, you know, moving where the front is. Here we can't do that because I can remove from anywhere in the bag. I can remove index 2. And I can't, like, there's no fancy thing I can do where I'm like, oh, okay, make the front index 3. Well, no, because the front is still 0. Because with a bag, I'm allowed to remove from any arbitrary location, not just the front. If it's the front, I can be like, okay, the front's now 1. Great. But if I remove 3 or 2 or 17 or n, I can't do anything fancy to be like, oh, okay, because I now have a gap in the middle of the information. We might get lucky that the gap is created at index 0, and I guess we could make it so the front moves down 1. But if we have something of size n, removing to the front is going to be like not very often. So no matter what here, we have a gap when we remove. Where with the queue, the gap was always at the front, so we can kind of pretend that, well, it wasn't a gap. It's just the front's now over there. With a bag, we could be removing from anywhere, so there's going to be a gap. Was that better? Did that help? So making index 3 that you remove equals to null wouldn't get rid of it, just makes an empty space. Exactly. So, like, sure, it gets rid of it, but now I've got this gap in my array bag, and gaps are a problem because, like, if I want to do a linear search for thing and then suddenly there's a bunch of nulls in the middle of, like, that, we're asking for, that's a recipe for disaster there. Why can't you just delete the gap? Well, because it's an array, right? It's the piece of memory. You can't delete it. It's what's there. It's physically there. Now, remember, like, when we make an indexed bag, pardon me as I'm all squirmy in my sheet. See, so I got a job today. Well, congratulations, by the way. But to your question about can we use something to keep track of the gaps? Yeah, sure. But now you're doing a lot of extra bookkeeping, and I don't know if that's worth it. So to ask about deleting the gaps, well, you can't, right? So I know we are implementing an indexed bag. And if you remove, well, it'll automatically delete the gap. But we have to implement what it means to delete the gap. And deleting the gap would mean moving everything down one. So let me go back to Paint here for a second. I have an array. There, that's good enough. Okay, there's my array. Right, I've got stuff in here. Let's draw this out. A, B, C, D, E, F, G, H, I. Okay, and we have 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. With the Q, if I remove this, if I took the A out, oh, now we have a gap. But if we say, no, it's not a gap. It's just the front is now 1. Suddenly, we are never capable of introducing a gap into our array queue. But with the bag, we can remove any of these. And I take that out. Okay, great. Now I've got this gap at index 3. What do I do? I mean, there's a lot of things we could do. But a really easy thing to do is just, we'll fill the gap in. And the way you do that is you just, okay, you take that, you do that. You take that. And you move it there. Take the G. I know I'm destroying my array, but deal with it. Move the H down. Take the I, and that there's no way I can extract. Whoa! Sure, let's keep that. And you move the I down. Great. So now we've closed that gap. But we don't want gaps there. And you can't just delete the index because this is an array. An array is just, you think of it contiguous memory, right? It's just information in a chunk of RAM. So you can't just delete it because it's like physically there. We can pretend it doesn't exist. We could pretend we delete it by managing these gaps somehow, but that's what we need to do because we're implementing the bag. Okay. So, okay, okay. We need to just expand capacity. Yeah, we want add, remove, Boolean, get count, is empty, size, and iterator. Oh, another boop. How do memory slots empty then? What if they're physically there? I'm not sure what you mean. Like, well, if the information is never referenced again, the garbage collection is going to be noted that it can be rewritten. Like if you lose reference to like a variable in memory, then Java's going to go, oh, okay, well, that's not referenced anymore. So I can overwrite that. But it's not deleting it. It's just like, it's been marked for, okay, I could put something in there again. In fact, here's a funny little thing. So here, I'm going to show you something real neat here in Java. Java does something nice. If I come along and say int array ASD equals a new int array of size 5, right? And I say for I equals 0, I is less than 5, I plus plus, and then I say s out ASD at index I. So, and it's even going to say, hey, this is uninitialized. So if I run this, like you see that, okay, well, I created an array of size 5. I didn't put anything in there though. But by default, I printed out index I. So 0, 1, 2, 3, 4, they're all zeros, right? And that's because in Java, by default, you get these default values for whatever's in there. If you turn this into integer, by the way, of the object, well, the default is now going to be nulls, I believe. Let's just make sure I'm not wrong. Yeah, they're nulls. But you get this default value. Now here's something that's probably impossible for you to read right now. Settings. Turn this to, what was it, 24? Okay, that's not a lot better, is it? Settings. Editor. Font. All right. So here in, this is C, or C++, okay? Sure, it looks a little different, but it's really not that different. I'm creating a new array of size 5. This is just the way I'm doing it. And then I've got a for loop. This should look very familiar. And I'm going to hit run. Okay? Now in Java, by default, it was like, oh, it's an integer array, so it's all zeros, right? If I run this in C++, I see, all right, negative 13,088, 0, negative 13,168, 0, negative 12816, 007, negative 13088, 0. It's garbage. It's nonsense. That's meaningless. But that's because all it did is says, oh, okay, there's a chunk of RAM that's size 5. But there's already like zeros and ones in those chunks of RAM. So when I told C++, well, just print out what's in there. It's like, oh, okay, well, these zeros and ones as an integer is negative 13,088. Why? I don't know, just because it was what happened to be in there. But, so in C++, it doesn't go and automatically put in these default values. It'll just tell you what's there. In fact, here's a funny thing. How big is this array? Who could tell me? 5. How many array indexes did I print out? 10. Yeah. And apparently C++ was okay with that? See what happens if I try that in Java. Let's do 10. Run. Uh-oh. Array index out of bounds. But C++ is like, yeah, sure. Here you go. I'm just wondering why we are using C++ today. You mean in general or today? Because it's only been for like 2 seconds right now. I was showing you the C++ to show you how the memory works. That's all. And like I was only there to show you that Java gives you the default values. It goes in and overwrites whatever was in the RAM locations with zeros. Where C++ does no such thing. It just tells you what's in there. And that's because the computer knew, well, those chunks of RAM are available for me to use. There's zeros and ones in there already, but whatever. I mean, I can overwrite that. It's fine. So when I print it out, it just tells me what was already in there. So that's why I was showing why there's there. I think you meant gosh stuff. I don't know. Yeah, so that's enough with the C++. Go to MK and say this is a Catholic school. What's MK? What? I don't understand. It's a res. Crazy res. All right, I don't know what you're talking about. But anyways, okay. An array index bag. I was just talking about what we need for a bag. An array index bag. What do we want? Well, we want an add that'll just like append. This will add something to the end. An add where we specify the index. Remove from a specific index, set something at a specific index, get something from an index. So this is like get but don't remove, and an index of. Tell me the index of a given element. So we're going to start by implementing in an array bag, an array indexed bag, pardon me. But only areas of note are presented here, and some methods are skipped. See array index bag implementation for the full implementation. Okay. So, here is the start of our array indexed bag. Let me, no, not that one, this one. What topic are we on? Expand 13, 14, 15, okay. Wait, why am I looking there? I want array index bag. Okay, here we go. Here we go. Public class array index bag of type T implements an indexed bag. So far, so good. Private static final default capacity. Okay. Private static final int not found -1. More on this in a moment. This is entirely unnecessary. You'll see below, but I'm just doing this because I like to use constants to make code more readable. Are an array of type T called bag and an int rear. That's it. And if you look at all this, if you look at this, this is the exact same beginning as the array stack. The only difference is it's not a stack, it's a bag, and we have this not found. Protected. Oh. Yeah, why did I put those as protected? Maybe I explained that. Maybe I explained protected. Good catch on the protected. Let's see. I guess I never explained protected. So protected is this little, it's a little bit different. In fact, they could probably be private. I don't know why they're protected. Protected. What it means is, so there's private, there's package private, there's protected, and then there's public. Private and public are the two big ones, and package private is what you get when you don't put anything in front. If you just say, like, for example, if I just said that, this would mean package private. So let me explain. Private means this is only accessible from within this class and things of this type. Public means it's accessible from everywhere. Package private means it's accessible to anything inside the same package. So if you've started assignment 3 and you look at the package, like the maze package, if I did package private, any class inside that package could access those private variables. But if I'm code outside the package, I can't. If you're scratching your head going, what? It does not matter. Protected is, and someone should double check this to correct me if I'm wrong, because I might be getting this backwards, but protected means it's like private, but things in the class, in things that are a subclass of an indexed, of an array indexed bag can still access this. But I'm pretty sure I could get away with turning these back to private. I don't think there's any need for me to leave them as protected. All right, in Java, protected means the member can be accessed by any class in the same package and by subclasses, even if they're not another package. No, a protected variable is not visible outside the package. There you go. Cool. Again, though, I'm pretty sure I could leave these as private and it would work just fine here. So don't worry too much about it. If I didn't even go in on it here, it doesn't matter too much. All right, our constructor, well, the default one just calls the constructor that takes the capacity, but with default capacity, create a new bag of type or a new array of type object, cast it to type T, and then rear starts at 0. Great. Our expand capacity. We know we're going to need an expand capacity. How do we do it? Well, this is the same as the one we've been doing for our stacks and our other original array-based collections, but not the queue. We create a new array of twice the size, cast it to type T, copy everything over to the new one, and then set the bag field to be referencing the new array we just made. That's it. Expand capacity. Now I'm introducing a bunch of other things. I have this shift left, shift right, sentinel index of, add, ooh, why is this commented? Sentinel index. Oh, right. More on this in a minute. Add, another add, set, get, remove, index of, contains, get count, is empty, size, iterator, toString. Great. There are a bunch of extra things in there. So we've got our expand capacity. Okay, wait. Okay, this looks nearly the same as array index bag. What? Oh, array sorted bag. Pardon me. I'm in the wrong section. All right, here we go. Okay, there are a couple of things worth noting. We are importing something called iterator Iterators are used for iterating over a collection. More on this later. The use of a constant not found that's set to -1. So we'll use the value -1 as what we call a sentinel value. And it's to mean something was not found. So it's a value that in the context of how it's used has special meaning. If you're looking at this code for the first time, -1 may be very... Okay, so the reason I'm making it a constant is... Let me go see where I use not found. So here I have a method, a private method called sentinel index of. So what does it do? Find the index of a specific target element. If the element does not exist, return not found. So this just does a linear search. It's using the fancy iterator, so you see the for loop looks a little different. But this is just doing a linear search. And as soon as I find the thing, I return the index. But if I ever get to the end, and I don't find where it is, I return -1. We've done this before in stuff, like with, I think in an assignment 1 and an assignment 4 last semester. But we return -1. But the problem is, if you write -1, if you're looking at this for the first time and you're like, what the hell, what's -1? Sure, you could probably deduce like, okay, well, they're looking for an index, and I guess if they don't find it, they're returning -1, which makes sense because it's negative value, there's no negative indices, right? Obviously, you can figure that out, right? But you know what's more obvious? This. Oh, and if they don't find it, they return not found. Oh, okay, so it's just this variable. What do we got here? Oh, it's a constant. It's -1. Its value is -1, but I'm just going to refer to it as not found. So this is just making use of a constant for like readability. Same with default capacity was like that though too, right? I could just put in 100 here and you could be like, what the hell is 100? What does that mean? Why would I do it with 100? Where if you see, oh, make this with some default, just some arbitrary default capacity. Okay, cool. So yeah. All right, we'll end there and we'll pick up here on Friday. Yeah, cool. I'll stop the recording, but I did see